In the today lecture, we do discuss about the perfect magnetic conductor (PMC), which are the ideal surface and which are used as a magnetic field for the perfect conductor of the behavior. And at the surface, tangential magnetic fields zero, and normal electric fields becomes zero. But PMC of the imaginations, yeah, assumptions, we can say that we can do by the PEC, perfect electric conductor. It is the opposite of that. And PEC, electric field, which does not exist, and PMC, magnetic field, does not exist. That is the difference between them. Now, what is the characteristic of PMC? Basically, PMC, which becomes the perfect reflections for the magnetic fields, and there is no energy loss, and it does not have any surface current, and it exists but surface magnetic current, which is the imaginary form. Now I will tell you what is the wave behavior on that. Basically, in the electric field of the reflections becomes at the same phase, but in the magnetic field of the reflections becomes the opposite phase. Now a question is arise, what is the where is the use of PMC? Basically, it is used for the antenna design, artificial magnetic conductor in the form, and metamaterials, meta surface, PMC, and behavior. It becomes the create, and it is used for the simulations in symmetric conditions, like as perfect magnetic conductors, which are used for the boundary and symmetric planes. PMC is not finding in the real worlds because any perfect materials of the conductor which is not found in the universe. It is used only for the simulations and theoretical analysis, but some engineers form by the artificial magnetic conductor AMC, which are used as a PMC approximation behavior, like as high impedance and surface EPG structures. If I will tell you what is the mathematical representation of PMC, basically the tangential component of the magnetic field becomes zero, and normal component of electric field becomes zero in the case of PMC. Now I would explain some scattering boundary condition SBC. So basically the specific boundary condition which are used for the electromagnetic simulations, acoustic simulations, and wave physics problems, and the main purpose of that is wave computational domains and reflections of the finish, and it is used for the domain open space, like as infinite domain. Now a question is why is scattering boundary condition is essential for that. So basically it is due to a finite domain, and if boundaries are not observed, then wave reflect to the boundary, and due to which simulations becomes wrong. Now a question is arise, what is the use of scattering boundary condition? So basically it is used for the antenna radiation pattern simulations, wave propagations, electromagnetic, acoustic, seismic, and radar cross section analysis, and it is used for the optical devices. There are some limitations of that, so it is not for the high accuracy, and it is not used for the large domains. Yeah, it is used for the proper meshings. If you want to high accuracy, then PML is best option. Now again I want to explain another concept which is called periodic boundary conditions. Basically it is the specific types of boundary condition which are used for the when any structures or materials is repeated. It is used for that, and basically the main use of that is electromagnetic simulations, metamaterials, photonic crystals, antennas, arrays, waveguides, structures, main use of that. Now a question is arise, what is the main purpose of that? So main purpose of periodic boundary condition is infinite structure simulations of the simplify, and computational cost minimize, and wave interactions study.